Hello Math 2, this is Mrs. Bricky, and this video is for Unit 4, Lesson 4 on proportional segments. Sorry, in class we did a little exploration, but let me just pull this up. So if we have 3 parallel lines and we have a couple of transversals that are cutting those lines, you can see that it creates 4 different segments. So I have them marked A, C, B, E, C, F, and E, D. Well, if I kind of move my points around, you can see that the length of those segments change. But something that's interesting is that their ratios do not change. So they always, AC divided by CF, these two are in the same ratio as these two, BE divided by ED. So if I change the location of BC, those proportions are always equal to each other. And I can kind of move this situation and change it however I want, and we still always have these 2 ratios that are the same. So this is a theorem. If we have 3 or more parallel lines that are intersected by 2 transversals, then they divide the transversals proportionally. So for this diagram that I have right here, that means that A divided by B is equal to C divided by D. And it's actually also the case that A divided by C is equal to B divided by D. So we're going to use that idea to set up some proportions to help us find some side lengths here. So right in this first diagram, we're looking for the value of x. So you can see that we've got these parallel lines that are being cut by a transversal. So I like to start with my variable that I'm trying to find, x, and I'm going to put that over 52. So if I do this one divided by this one, then I will also do this divided by this. So that will be equal to 18 divided by 45. So to solve for x, I would multiply both sides of this equation by 52. So if we multiply by 52, this one cancels out, and we can calculate our answer in the calculator. And it is 20.8. You can sometimes use some logic to see if your answer seems reasonable here. The 45 is a little bit shorter than the 52, so the 18 is a little bit shorter than the 20.8 that we got, and that kind of makes sense. Okay, in this diagram, we're trying to find the value of y. Here's y. I'm going to divide y by this length, which is not on the diagram, but we can calculate it because we know this full distance is 32, so 32 minus 18 gives us 14. So y divided by 14 is equal to, well, for my other diagram, for my other little fraction, we're going to do 27 divided by 18. So to solve for y, we would multiply both sides of our equation by 14. Oops, it looks like a 4. My 1 didn't take. Let's see, 27 divided by 18 and times by 14, we get 21. Okay. Here we're trying to find the value of x in the diagram, so we can set up our proportion to help us solve. 3x plus 1 divided by 12 is equal to 24 divided by 18. So we can multiply by 12, and that's going to cancel the 12 out. So we have 3x plus 1 is equal to 24 times 12 divided by 18 gives me 16. So to finish up, I'm going to subtract 1. and divide by 3. So I get x is equal to 5, and that was my goal, to solve for x. Do we need 3 parallel lines in order to apply the idea of proportional segments? Well, think about the case where, let's see which points I can move around here. Think about the points where A and B get closer and closer and closer and closer to each other until maybe they are exactly the same point. In that case, I don't actually even need that third parallel line to apply this theorem, and we still have proportionate segments. So if I move point C around, for example, I still have these two ratios that are the same. So if I have just two parallel lines, or if I have a line that is parallel to one side of a triangle, that is going to divide the other two sides proportionally. So what that means is that w divided by x is equal to y divided by z, and also w divided by y is equal to x divided by z. So you can kind of set up the fraction either way, whichever way kind of seems the most logical for you when you're looking at a diagram. So in this diagram, it says that EB is parallel to CD. So we do have a segment that's parallel to the side of the triangle, and our goal is to find the length of BC. So I'm going to put an X there. So one way that we could set up our proportion is that 15 over 12 is equal to 10 over X. That's kind of a way that you can just immediately see the proportion sort of aligns with the diagram. If you don't like having x in the denominator, you could maybe think of other ways to set it up. For example, if we do x divided by 12, that's going to equal to 10 divided by 15. So that's another way we could set it up. So if we solve for x, we'll multiply both sides of my equation by 12, and we get x is equal to 8. You would get that same answer if you solved using this equation here, maybe by first multiplying by x, and then going from there. It's the same. So if you set up your equation and you're like, oh, that looks hard to solve for x, you can try setting up a different equation, or you can kind of think of other ways, including flipping it over to find a way that makes sense for you. Okay, let's see. Find the length of segment BF. So I'm going to put an X on that segment, and we know that AB is parallel to EF. So let's see. In order to use this theorem, we need to know the length of this segment right here. So if that full length is 7.5 and if this shorter bit is 3, then this would be 4.5. So if we set up our proportion, let's see, I'm going to do x over 4.5 is equal to 4 over 3. So I did x over 4.5 equal to 4 over 3. So that works as one way of setting it up. If you saw a different way, that's probably okay. There's several correct ways. We're going to multiply both sides of our equation by 4.5. And that gives us x is equal to 6. Okay, we want to find the value of x. So if we know that this whole length is 40 and we know that this part of it is x, that means this part of it is 40 minus x. So when we set up our equation, we can do 40 minus x divided by x is equal to 35 divided by 21. And again, there's multiple ways you could set this up. This is just the way my brain first saw. So we're going to multiply both sides of our equation by x. So now we have 40 minus x is equal to 35x divided by 21. We can multiply both sides of our equation by 21. Because this side is a binomial and has more than one term, we're going to distribute the 21. The 21 on this side cancels. 21 times 40 is 840. So we have 840 minus 21x is equal to 35x. We're going to add 21x to both sides of our equation. That's 56x. And now we're ready to divide. When we divide by 56, we get x is equal to 15. So that means that this piece has a length of 15 and the other piece has a length of 25. Okay, segments DE and BC are parallel. So we've got these two parallel sides. What are the coordinates of point D? So our goal is to figure out where D is. So we're going to think, let's write down some lengths here. If A is the origin, this is a length of 9, and this is a length of 3. This is a length of 15. It is a negative 15 on the point, but I can just think of how long this is, and its length is 15. And then the length here, maybe I'm going to call that x for a minute to figure out how long that is. So if I set up a ratio, a proportion with some ratios to help me solve, I'm going to do x divided by 15 is equal to 3 divided by 9. So solving for x, I just need to multiply by 15. And that gives me that x is equal to 5. So this length right here is 5. Well, that means that the coordinates of D, because D is to the left of B by 5 units, that means D is at negative 20, 0. Okay, our last little follow-up question here with this diagram is we want to think about the triangle ABC. That's this triangle. ABC. And triangle ADE. That's this triangle. And our question is, are these two triangles similar? And if they are, how do you know for sure? Well, I want to remind you that we have some parallel lines. Since we have parallel lines, we know that corresponding angles are congruent. So we know that the angle here and the angle here are equal to each other. And also, we got a right angle right here at the bottom of the triangle. And so definitely these two triangles are similar by angle-angle similarity. We know that if two angles in a triangle are congruent to each other, then the triangles are similar. So yes, triangle ABC is similar to triangle ADE. Okay, that's it. Make sure you get your assignment done. If you have any questions, talk to your teacher. Thanks a lot.